Hi, everyone. Thanks for joining. My name is Lean, and I'm a solutions marketer at NI. And today I have with me 3 LabVIEW veterans that we've brought together to discuss modular design in LabVIEW. If you've heard me talk about LabVIEW in almost any of our videos out there, you've heard me talk about how data flow and graphical programming help make designing an application a little bit more intuitive. Even then, though, any large or complex application can get difficult to visualize. And that's where modularity comes in, breaking it down into modules and having or using a good framework or architecture to connect these modules together. This can help improve testability, usability, and overall success. So I'm planning on picking these LabVIEW experts' brains on modular design, what makes a framework a good one, and how you can choose the right one for your application. Before we jump in, though, maybe we can go around and have everyone introduce themselves. Alan, do you want to start?
Oh, sure. I'll go ahead and start. I am Alan C. Smith. I have been doing this forever. And by forever, I mean this is my 30th year of programming, developing LabVIEW applications. I've been currently a partner. I've been a partner most of my career. I worked at NI for a while. I'm a certified architect, certified embedded developer, certified instructor. When I was at NI, I was on the Active Framework feature team. I'm still very, very active in that community. And I currently provide services as a consulting software architect, and I can help you with your software solutions.
Awesome, thanks. Daniel?
All right. It's great to be here with these guys. Of course, we've known each other for a long time. And having Alan here as a 30-year veteran, that's really impressive. I gotta give applause for that. I've probably got just a couple years less than that, maybe about 28. Yeah, I've certainly been using LabVIEW for a long time. Currently, I am one of the owners of Prime Test Automation. We build machines for manufacturing automation and, of course, test and measurement. LabVIEW is our preferred platform. But we do mix in the robots and the PLCs and typically connect all that together with LabVIEW. So when we talk about modules, those are also modules. So really excited to see where this discussion goes, and happy to be here.
Thanks, we're happy too. Jim.
Hi, Lean. Hi, gang. So my name is Jim Kring. I am employed by a founder at JKI.net, and we are an alliance partner of many years also. And we really believe in graphical programming as a way for engineers and scientists to quickly and effectively build systems. And at JKI, we started out writing software to help scientists and engineers automate data collection at Lawrence Berkeley National Lab, spectroscopy equipment, and from that sort of grew JKI. And today we help scientists and engineers in kind of Silicon Valley Bay area automate their high-tech stuff and get it to market very quickly with high quality. And on the LabVIEW side, I've been in the LabVIEW Champions program, I think, since its inception. I'm a co-author of LabVIEW for Everyone 3rd edition, which is a textbook for all you young kids. It's a big, heavy thing.
I think I have a copy of it back on my shelf.
Yeah. And I also have been, for many years, speaking of modularity, have been using and working on LabVIEW frameworks. I've been doing object orientation in LabVIEW, kind of helping develop features and components that kind of express those features since before LabVIEW had object orientation in it. The last thing I'll say, and I could say a whole lot more about the open source and other stuff I'm doing, I'll save that, but I actually designed the little frame, cube frame icon for the abstract class in LabVIEW. And I designed that in Microsoft Paint by hand. And so as we start talking about modularity and stuff, like, you're talking to the guy who designed this little cube in Microsoft Paint.
I was just going to say, it seems like we have the right people here on the call to have this discussion. Well, thank you. Thank you. We're honored to have all of you. So let's start it off, and maybe let's start off with the why. I already kind of hinted in the introduction, but why do we want to develop with modularity? Maybe Dan, you want to start us off?
Sure. So this is true of any programming environment, not just LabVIEW, but LabVIEW has some unique features that kind of point you in the right direction, I think. When we talk about modularity, what we're really talking about is something called functional decomposition. And it is the idea that you can express what you're trying to do in a concise statement and make your software look like that, so that each module is fulfilling whatever that statement is. Why LabVIEW for that? Well, LabVIEW gives you a pretty strong hint of where to start. Everything in LabVIEW is a VI, a virtual instrument, with a front panel and a block diagram. There's a little run arrow, and it's got inputs and outputs that you define, and it can run on its own with nothing else. That is a very natural starting point for a module. Then you start to get a collection of these VIs, and you start to create this hierarchy. And then you start to think about ways of organizing that hierarchy into things like libraries, classes, and then eventually into frameworks. And within your framework, you can also define modules. And I think that's where a lot of this discussion is going to go with these guys, is talking about some of the frameworks and how the interactions work, and some of the real advantages that come with that. We might start to mention frameworks by name, and I think that's where it's going to get really interesting.
I call mine Little Jim.
There you go.
So Jim, since you have a little Jim, maybe you could give us your thoughts as well.
So why modularity? Why the discussion? So I think that there's kind of at least a couple important aspects, and two that come to mind are: don't repeat yourself. And so if you have a module, typically then you can reuse that module. So if you have a module, as Dan was describing, a VI that encapsulates some functionality, you can reuse that in several places rather than having the code copy. And so that then scales up, because if you're using it in 10 places and you add a new feature to the module, then you get 10 times the return on investment, right? And so the modularity allows it to sort of scale in that way. And that's sort of like the looking out perspective on modularity. There's also the looking in perspective on modularity, which is, if we can, like Dan was saying, decompose the functionality of the system and group it and create groups that are, let's say, narrow enough in focus or limited enough in focus to do, just one or two things very well. And so thinking about the graphical diagram, if we zoom in and create a window of only the things that we need to worry about for a specific task, which could be like finding the average value in an array, right? We can, for that moment, step into that room, that context visually, and forget about everything around us for the moment, and manage these 4, 5, 6, 7 components of this module. And essentially that allows us as engineers to be able to sort of solve problems effectively by managing a manageable number of pieces at a time. And so it's kind of that looking out, scalability, don't repeat yourself, and then the looking in, focusing on a scope where we can actually fully understand a smaller problem and solve it very well.
Nice. I really like how you put it into stepping into a room.
Zooming in and zooming out.
Zooming in and zooming out, maybe. Maybe that's something we could talk about later.
Just setting you up.
Yeah.
Okay. So I'll weigh in on that. Why do we do anything in software? Obviously we write software to solve problems, but then we actually have to do the work, and modularity is about doing the work. Any software architecture, any design, any structure that we build in, its sole reason for existing is to make our jobs easier, make it easier to write the software, make it easier to deploy the software, which often junior developers don't think too much about deployment. Make it easier to test the software as we're developing it and after it's been completed, and make it easier to maintain over its lifespan. It's not an original quote to me, but I say it a lot, and so people in the LabVIEW community associated with me is, write your code on the assumption that it's going to be maintained by a homicidal maniac who knows where you live. You want to keep that individual happy, or at least thinking about other people. So that's why.
It may or may not be yourself.
You or
I've been accused of maniacal behavior in the past. Fab likes to say, "Be kind to your future self." I live in a darker world than she does, so I go with the homicidal maniac meme. But it's all the same thing. I mean, writing software is hard. It's a hard, complex problem. If you look at human beings, we can only think, and Jim, alluded to this a little bit. We can only think about 5 to 7 things at a time. Like concurrently, I can have 5 to 7. I think software developers, we have to hold on to like 9 typically. But we just have to, we're juggling these things. And if you can only look at 5 to 7 things at a time, and you're talking about a large application like LabVIEW itself or Microsoft Word or something like that, there's more than 5 to 7 things going on in there. So we need to structure our code both to make it easier to do the business of writing software and to also manage our intellectual load. The good news is that this all scales. So I can only think about 5 to 7 things, but if I go look at a module, maybe it's got 5 to 7 things in it. And then each of those pieces is 5, and so on and so forth. So we benefit greatly for all the reasons that I've mentioned. If we can take our software application in its design and break it into these manageable chunks, they're easy to test. They can be, if you're building modular code, you can deploy the software before it's fully complete to see if what you have works. Maintenance is a lot easier because we tend to know where the problem is going to lie. And again, we can manage those 5 to 7 things in our brain at a time. So that's really the why. When you get right down to it, we're going to write all of the same code to solve the specific problems. We're going to read the DAC card in a certain way. We're going to display something on the UI in a certain way. And so modularity is about partitioning. Where do we put these pieces, all these functional pieces, so we can find them again?
It's sort
It's
of
really
like
that simple.
I was thinking about language when you were talking about that. Like we have these letters that like represent like sounds, and then we put them into words, and then we chunk them into phrases, and then we organize them into sentences with grammar, and then paragraphs, and then the story, right? And so
the famous 3-paragraph essay that we all wrote in middle school, right? The intro and the 3 topics and the end. There's 5 things.
Initialize, configure, measure.
Right.
Yeah.
I love that that's so universal. I grew up
It's very human.
the other end of the world, and that was universal to me. Jim, you're the king of analogies today.
How many people in a rifle squad? How many people in an executive meeting? Right. If you've got 12 people in a meeting, nothing's getting done. If you've got 5 people in a meeting, you get work done. Software's the same way. If I got to deal with this hodgepodge collection of all the little bits and pieces that make my software go, good luck.
Yeah. So then you used the term before, we had talked before that you had mentioned it was like a fractal. Yep. So it's a repeating pattern as you get zoom, as you dig down, you keep seeing it's a repeating pattern. I thought that was a really elegant way to describe it.
Yeah, and we actually saw that, Daniel, you alluded to that too, because we start with the VI, which is a collection of function calls, LabVIEW primitives, LabVIEW functions that we bundle together to solve a problem, right? And now I've got a VI that does a thing, and I can have several VIs that do a thing. I'm really big on object-oriented design, as anybody who's spent more than about 30 seconds with me knows. So I start to put my VIs in libraries and classes. The VI does a thing. I should be able to tell you what my VI does in a sentence or two and have that be meaningful to you. Same with my library or my class. So if I have an instrument driver, what does this instrument driver do? It controls Keysight 34401A multimeter. That's its job, is to expose that functionality to me. Okay, cool. That's an example of a library or a class. You know, our frameworks, the popular frameworks in LabVIEW have their modular elements. They tend to all be, you know, threads of a bunch of things going together, and collectively we've come to term those things actors. So all our frameworks have these actors that do some task, and I can tell you what that actor is. I should be able to tell you what that actor does in a sentence or two. And then we build our systems based on, you know, groups. You have groups of actors that solve a more complex problem. So it all does scale, which lets us get into bigger and bigger and bigger problems, or contribute our own useful piece to a larger problem. You know, network endpoints, for example, it's one specific collection of actors and classes. It solves one problem in a system that's a lot of people use. I mean, people using systems, I've never talked to them. So
another dimension that kind of came to mind is like the maintainability over time. And so we can decompose, modularize, and assemble a system of components now to solve the requirements. And over time, the requirements are going to change as new equipment fails, new equipment comes in, the requirements change, computing hardware changes. And so
a new manager comes on board, you know, whatever.
And so in addition to not wanting to make the future software engineers or team members upset because our code is hard to maintain, we can also sort of orient around thinking about those human beings in the future whose job it is to add a feature to the code. And, you know, they're gonna, you know, get a performance review, you know, a raise, you know, have to work long hours or short hours, depending on whether or not like our code is sort of manageable for doing the change that they want to do. So, you know, we can be kind. They call it like empathy-driven coding. I forget the term. But
Sam Taggart's real big on talking about that sort of thing. You know, software, developing software as a human activity by humans for humans.
So thinking about the fact that we're creating some entropy in the universe and handing it to somebody and saying, hey, you know, every morning you're going to get up and have your coffee, and it's your job to keep this organized.
Good luck.
And hopefully that process doesn't increase the entropy in the universe any faster than it has to. And they can go home at 5 o'clock and pick up their kids from school and have a smile on their face.
I don't think anybody went into engineering to make the world a worse place.
I like that. That's a good quote right there.
That was nice. You started off with homicidal maniac.
But we're making the world a better place.
We are making the world a better place. No, I like that. We had the two views of empathy and kindness versus self-preservation from a homicidal maniac that knows.
Good karma's cost effective. You do the right thing for the right reasons, and it comes back to you, and it winds up. It really is. You know, we all have to draw this back to a bottom line somewhere, right? Somehow we're all in some business activity. We're all doing something. We have to justify our activities to the people who have the money and are spending it. And the simple fact is that doing it right, even if it doesn't look like it at first, because doing it right takes time, doing it right is an investment that over the long term and or even the medium term doesn't it pays off. It pays dividends. Great example. When I first went to NI, I hadn't thought about this in a while. When I first went to NI, we were doing a bunch of stuff for semiconductor fabs in China, as it turns out, and we were pulling some late nights, putting together some semiconductor test systems, and I was doing what I do, which involves, you know, a lot of classes and OO and modularization and all the things we're trying to talk about today. And the fellow that I was working with didn't get it at the time because he said, hey, these are prototypes. We're just trying to get something out the door to show that NI products will solve the problem. We don't make something good right now. Okay, I'm not going to mention his name because I think he's learned. And I think he learned a couple of weeks later when we were there at 10 o'clock at night, and he came downstairs and he said, Alan, I'm so sorry, we're going to have to stay late because we need a new thing. And this new thing is going to take you a while. I'm like, all right, I've got this. And 10 minutes later, I sent him a message that it was done. And that's a little dramatic, but that's the goal. You know, we modularize our software with an eye toward containing specific problems and allowing us to quickly make changes when we need to. And we don't always get it right. Some changes are going to be really dramatic and take a lot of time. Software is a hard problem. You don't really know what you're going to build until it's done, quite frankly. But there are things that we can do. They're good practices, good hygiene, as I like to say, that if we consistently do those things on balance over the long haul, our jobs get easier. We get to go home to our families, and the people who take over maintenance of our work get to go home to their families.
You don't
in a
have to
timely
stay in
fashion.
the fab overnight.
Say what?
You don't have to stay in the fab overnight.
Right.
What was in the fab?
Because I don't. I work really hard to not have to work really long.
I like that.
I have a child, and I want to see her grow up. I don't want to spend it in a fab or a factory, or even someplace cool like SpaceX. And I want to come home and live.
So the jargon that we're all hinting at here is we have to spell it out, right? It's the encapsulation and abstraction.
Literally what I was going to ask you, Dan, because I know you mentioned it last time.
Thank you, Dan. Thank you.
Here's the jargon for you. So that's the concept of hiding all that complexity, those lower layers of things that hopefully you've figured out or others have figured out in the past, and you are being given, and you could be given it, formally by a colleague, or you can download a package using the VI package manager. We have Jim here, right? Or one of the other package managers, but that's like the original, the OG package manager, right? So you have all this reuse that's out there in the world. You want to take advantage of that. Those things are nicely encapsulated for you. They're packaged, which is like another whole level of encapsulation, right? Because it has documentation with it usually, and it's deployed. So it's all about reducing those number of concepts that you have to keep in your head all at the same time when you're trying to solve a problem. And it's something that the tools are there for us in the LabVIEW ecosystem, and it's just a beautiful thing.
Well, and they let you think about your software. Each one of these layers of modularity lets you think about your software at the next higher level. I was just thinking, as you were talking about packaging something up, why do we do that? I mentioned, you mentioned device drivers or whatever, and it's like running a device drivers, it's hard, it's fiddly, and it's frankly tedious, right? And so why write that more than once? Let me put that into a body of code that I can give to Dan, or Jim can distribute with VIPM, and then somebody else can download the 34401A driver, and he can take a measurement. And so now he can think about taking a voltage measurement. And it's like, I don't have to think about the instrument. I just know that I'm going to call this VI that's getting me voltage back. So now I can think about the thing that I'm trying to measure and not how I measure it. And then I can go a level up from that. And it's like, I just got some data. Hunter Smith had a GDevCon presentation from last year on UIs, which I recommend going and looking that video up. And he talks about, going from this raw data all the way through telling the story out to the end. And so I think it's probably an analogy there to what we do, because we've got to get down to the nuts and bolts of whatever we're doing, but we have to build that up into some coherent solution to a problem. And modularity helps us think at these successively higher levels of how things are supposed to work together.
Okay, I'm convinced, and I hope everyone's convinced. Modular is the way to go. And we've kind of hinted that LabVIEW inherently almost lends itself to modular design. So next time I'm developing a larger application, I need to find a good framework or architecture, or maybe build one myself, probably not. So maybe for this next part of the panel, you could share your preferred frameworks, and you can name your preferred ones. I want you to name them because I know you each have a different answer. Why you like it. Help us understand basically what makes a framework a good one or the right one for an application. And then maybe I'll start with Jim this time.
Great. So in terms of what would make a good framework, facilitating modularity is kind of a key to it. So we want something that's going to be flexible, so kind of easy to click things together in a configuration, swap them out, maybe even dynamically. And we want to be able to like scale up to larger systems with multiple components. So frameworks that enable us to do that relatively quickly and are easy to kind of develop within as well, that require us to focus, let's say, on kind of our business logic and the rules for this. What are the things in the system? What do they do? How do they talk to each other, rather than, you know, how are the object lifetimes managed, and will it shut down everything if the user presses the X button when this happens? Like, we don't want to have to worry about those things, because those are framework design level problems, not system design problems. And then there's a couple other aspects. We started talking about like kind of sharing, collaboration, and reusing. So I think in terms of a framework, having something that has good documentation as to like, what does the framework do? How does it work? How do you add components into it? And things like that, make the user experience go well and help people be effective in building systems. And it also helps the framework maintainers understand, like, how does our framework work, and how are we going to add features and fix bugs, so that there's kind of consistency in the framework. And then thinking about support too. So frameworks are hard. I encourage everybody to try to build your own framework and then go put it in a corner and go find something.
It's like writing a sequencer, right?
If you're gonna ship it to a fab, you don't want to ship it on your framework that you wrote last week, with the new latest feature in LabVIEW that facilitates abstraction and modularity or something like that. And so you want to make sure that it's well supported, so that if you have questions, you find a bug, there's some mechanism for getting that sort of fixed and what they call like upstreamed. So if there's a community maintaining this, if you fix a bug and you tell them, hey, I fixed a bug, how do you get that bug fix or even little feature that you want included in like the 2.0 release of the framework when you upgrade, so that you don't have the same bug and have to fix it again? So yeah, flexibility, scalability around facilitating modularity, and then of course, kind of the documentation and community support are pretty important.
And use an existing one and don't build one.
Where possible, yes.
For production,
yeah.
Product software, yeah.
And Jim, do you want to walk us through your, I think we know what your preferred one is, but do you have a preferred framework?
Well, it depends on framework for what.
Mm-hmm.
For what? Because I mean, there are frameworks for like windowing systems and a variety of other frameworks. So probably let's say kind of like design pattern that I use probably the most often in LabVIEW is the JKI state machine. And it's basically a while loop with a case structure in it and an event structure in one of the frames. And it just uses a multi-line string as its sort of like, not so much a state queue, but as like an action queue, a task queue. And then it has a shift register with a cluster of data that kind of encapsulates that. And so I have long, in the domain that I tend to work, which is very quickly get systems like demo systems, prototypes up and running, being able to do things very quickly is important. And also doing things in a way that feels like it's using LabVIEW's features in the way that like you're kind of going with the flow, right? And over time, LabVIEW's added other features like objects, dynamic user events, data value references, and things like that, interfaces. We can kind of include those in our framework design. However, like for me, like the developer's usability of the framework, I want that to be as easy as possible and to not have to rely too much on external tooling.
Mm-hmm.
Just from a maintainability perspective, I want a casual LabVIEW developer to be able to kind of come into my code and to kind of be able to say, well, I could sort of maintain this. I see kind of how it works, how the pieces fit together, doing it in a way that's sort of, in Python, they say it's Pythonic, meaning it's done in a way that's consistent with kind of the standards and the style that the community has adopted, and it's going with the flow of the language's principles around kind of simplicity and things like that. So in LabVIEW, how can we create components and frameworks that kind of fit in with this idea of like graphical design and the features of LabVIEW. So the JKI state machine, it kind of, plops these native structures into LabVIEW and doesn't have external dependencies on a lot of stuff except for a few VIs to Q and DQ. So that's a preferred framework for a mode of development with a set of people in mind who are going to maintain it. And it's not the right one for every situation and everything.
100%. And that's why we also have Dan and Alan here to give their thoughts on their first go-to. Let's call it the go-to rather than preferreds, because you could, for the right application, you might have a different framework. But what's the go-to that you first go for?
So it will shock literally nobody who's ever heard me before in a prior presentation. It will shock, like I said, no one to know that my go-to is Actor Framework.
Actor Framework.
I was Actor Framework, yes. I was
And
the Actor Framework that ships with LabVIEW. I actually had been doing some very similar kinds of things prior to coming to NI. Stephen Loftus-Mercer turned me on to his Actor Framework ideas, and I've been involved with that pretty much ever since. So if you leave it up to me, if you hand me a design problem, leave it up to me, you're going to get an Actor Framework solution. Jim raised some very interesting points that I want to branch off on and kind of elaborate on. The first one is, of course, what are you trying to accomplish? If what you are trying to accomplish is a very linear, I'm testing parts, okay, or I'm doing a sequence of operations over and over and over again with like these steps that I kind of want to maybe mix and match, and everything is a very linear sequence sort of thing, I'm going to push you to test end as your framework. If you ask me to write a sequencer, I am going to beg you on my knees with tears in my eyes to please use test stand and not have me write a sequencer for you, because apparently we're all doomed to write sequencers over and over again, and we have an outstanding sequencer available in test stand. Buy is cheaper than build. We are expensive, okay? Even a junior LabVIEW programmer is expensive compared to what it would cost you to simply use test stand for that kind of problem. Now, as it turns out, in LabVIEW, 90% of our problems that we solve involve multiple parallel processes that talk to each other. In one, even something as simple as I have a single queued message handler and I have an event structure to capture user events, that's two parallel processes talking to each other. And it's a part of me that thinks that that's kind of an accidental way to get true modularity of a complex module. We got queues in LabVIEW, in LabVIEW 5. In LabVIEW 5, then they became official functions in like 5.1, I want to say. That's ancient history. And within 18 months, we were all doing queued message handlers of a very similar design. The details changed.
We had native by reference data. The single element queue was the first native by reference data value that I can think of.
Yep, that is true. But we got queues as a feature in the language of 5.1. And then like I said, in 18 months, we're all using queued message handlers. And here's a dirty little secret as we argue GQMH or JKI's tool or Actor Framework or any of a variety of others. They're all queued message handlers under the hood with different constructs around them to make them easy to use for certain problem domains. Because it's just so much of what we do. And that basic module of a single thread, queue-driven thread that's solving some particular problem, we see over and over and over again in LabVIEW. I've taken to just calling all of them generically actors. They're not necessarily Actor Framework actors, but they're actors. And they all interact with each other as building blocks of a large complex system. So if you're not doing test and for some very linear thing, and you're doing something where you have a fair amount of parallelism, then you're looking at, like I said, DQMH, you're looking at actor framework, you're looking at JKI state machine. There are others out there. AF and DQMH, I believe, have between them the lion's share of users. I believe that's true. I could be wrong. So which one of those do you choose? And that's going to go to, again, the problem you're trying to solve and the nature of your development team. As I said, in a vacuum, my first choice is Actor Framework, but I worked with a customer this year that, Actor Framework has some intellectual overhead. You do have to invest in knowing how to work with classes in LabVIEW before you can take that on. There is a bit of a learning curve. I think you can go farther with Actor Framework than DQMH. It's a personal opinion. I know there are some large DQMH systems out there, so there are people who will happily argue with me. But at the same time, I was, like I said, I was working with a customer this year, and I was looking at, bright guys, and we were taking their nasty, dirty, very sequential prototype and trying to build a real application out of it. And I looked at what their bandwidth was for learning good software practices, and they were not going to go up the OO curve. And so I suggested DQMH. And I think they would have been, we had to cancel that project, but I think they would have been very successful with that. It's, what are your developers going to be able to manage effectively? And again, buy instead of build, because even the most junior developer is expensive. And lots and lots of time go into these frameworks.
And I was going to say, we have a DQMH Dan right here that could talk a little bit more about that, Dan.
Yeah. So that's a good segue. So, no one was surprised when Alan. I thought for sure, Alan, you were going to say, by reference classes was your preferred framework. No, I'm just kidding.
No, they are just to be clear for the folks maybe listening to this who come from like a C++ background.
Classes inside of reference.
By reference class designs are contraindicated in a data flow environment. You can buy yourself a whole bunch of green if you're not very, very careful.
Anyway,
that said, that warning out
just occurred to me.
Embrace by value and go with it.
Yeah. So we'll talk a little bit about DQMH. I have developed using Actor Framework, and I think it's great, and it is very powerful. And from I'll call it more from a software engineering standpoint, it ticks a lot of the boxes, and it really does, sort of give you that sense of you are doing something, that feels like what Jim was saying, like this is what the platform is kind of. This is the flow. You're in the flow. You're using the classes. You're using the structures. You've got the Actor Framework palette. Comes with LabVIEW. There it is. But Alan is also correct. These are all queued message handlers. And it's a question of, and I talked about this a little bit before when we talked earlier this week about, you've got people who learn differently, who think with different mental models. You've got somebody, oh, I'm a visual learner, I'm an auditory learner, or I like to learn just by doing it, with my hands. It's kind of a similar thing for software development. If the way you break a problem down in your mind is, I've got this queued message handler and I want to send messages to it, and I feel like each message is a class and has its do method, you're an Actor Framework person. And I think that's great. If you have a mental model of, I like to look at my diagram and see that event handler and see that message handler, and I want my data on my cluster maybe to be a class or to be an interface. And if I make it an interface, then I have separated, I have abstracted, and I can use my DQMH module and do dependency injection on that interface, which was one of Alan's concerns. Anyway, what I want to talk about DQMH is, it is my go-to at the moment, mostly due to the infrastructure that is available with it. The scripting that comes with it, which is also there in Actor Framework, I should say. But it's gotten to a level now where you've got the tool chain being built, and there are free tools, like you've got the Panther Lab dashboard. I know you have Bowser the browser for Active Framework. You're starting to see the community respond and fill in all these wonderful things that make our lives easier as developers. And DQMH is the consortium behind DQMH is putting in a lot of effort into getting those types of tools out. And it's a very organized, very structured kind of a thing that has been put together. It's an international consortium. It's global. And we have meetings, and we talk about it, and we agonize over adding features, and we talk through, oh, this one developer over here is having this particular problem. What's the best way we can go about addressing that? I feel like the community is very active, and that feels reassuring. It's kind of what you guys were both saying. Is it you want to make sure that it's something that other developers are using. The more other developers are using it or familiar with it, the easier it is for you to show your code to someone. I could show my code to Alan, and Alan say, oh, that's DQMH. I know the rules. I can play by those rules and be functional and at least kind of know what I'm looking at. Or, oh, this is Active Framework. I know those rules. I know where to look. I know how to go find what's happening where and figure out what's going on. And that's tremendous, right? But yeah, generally DQMH is, we had a team of developers that were not all LabVIEW architects, and not all of them understood the ins and outs of object-oriented design in Active Framework. And so we were asked to go ahead and develop in DQMH, and it's been very successful over the last few years. And we've actually, one of the things we like to do as a company is we like to put our software out there and then invite our customers to go ahead and add features. Call me if you need me, but go ahead and add those features. And they've really been able to run with that, and that makes us feel good that that they're not just accepting something, but they're actually embracing it, living with it, expanding on it. So it's been really successful for us.
No, I like that.
I have another analogy for you that I think is,
yes.
So we talked about like virtual instruments, right, in LabVIEW, because we come from the lab. That's our sort of roots is, connecting to instruments, acquiring data, and then modularizing the hardware. So instead of a benchtop instrument that you push it and it's an oscilloscope and it only does oscilloscope things, we have these hardware modules that we plug into a computer that give us the analog and digital inputs and outputs. And then we have a software front panel, which is an oscilloscope, and we hit run and it gives us an oscilloscope output behavior. We can also have another VI that uses the same modular hardware under the hood, maybe not at the same time as the scope, but it reconfigures itself into a signal generator or some other type of device. And so now we have like virtualized the instrument. And so if we think about the VI that sort of has the business logic and the behavior of what normally would be a box sitting on the bench, and the way we instantiate another actor of the oscilloscope hardware class is we put in our order, right, on DigiKey or wherever we buy the stuff on ni.com. And we then get another one and we instantiate it by putting it on the bench. Well, when we start to have VIs that exist on our computer, and they include the business logic and behaviors and the buttons, the interactivity of an instrument, how do we then instantiate multiple copies of these? Well, we have to do that in software. And so these frameworks that we're talking about are essentially doing the work of taking your VI, which is the business logic and the rules and the behaviors and the UI of an instrument, and giving you the capability to, from a configuration, sort of decide, is this an oscilloscope application? Is this a spectrum analyzer? Or is it an application that uses one of each and then, becomes a tester? And so just the work of taking your VI and turning it into something that you can open multiple instances of, send them their configuration data, get results, have them talk to each other. So that takes a bit of work in plumbing, just like it takes a bit of work to package up a physical instrument and ship it to somebody, right? You got to UPS it and purchasing and all that stuff, right? So that's what the framework does in a virtual capacity. And then, I think in terms of why people choose frameworks and why they can be hard in LabVIEW is that when we go from the VI block diagram, which at an introductory level is a sequence of initialize, wired to acquire, wired to present in the chart, wired to uninitialize. We're doing a sequence of things, and then we make a copy of it. And if those VIs are not re-entrant, meaning you can't call two instances running in parallel, then we're sort of queuing up calls to those VIs. Behind the scenes, there's queues and stuff happening in LabVIEW's under the hood sort of framework compiler. But then as we start to use a framework that's spinning up multiple copies of our VIs, how do we then visualize that in a graphical way that is a lot like LabVIEW? And so I think none of these frameworks are bad. I think Actor Framework, from a sort of a purist perspective of which is going to be the easiest to maintain in the long term, fits that if you have a team of people that really understand how it works and can keep the picture in their head of like how this system is all configured and how the plumbing works. So they have a mental picture of the block diagram of the system. And the block diagram changes over time as components are, instantiated, connected, wired. And I think to really take tools like this to the next level, I know like Jeff Kay was working on like block diagrams where you could like plop something and it was an actor. And so you could actually drop things and they become actors, and you could use channel wires to connect the messages between them and things like that. And so the next level of these frameworks, I think, is having the community or NI or somebody working on high-level tools for visualizing the instances in your system, how they're connected to each other, like the piping of the messages and things like that. And that's a hard thing to do. Like LabVIEW itself as a graphical programming language is hard. Well, create a graphical programming language for systems that allows you to plop instances of components and connect them and visualize them as they change over time, start them, stop them. So it's a challenging problem.
We don't have that system level diagram. If you go back to, so there's a model in computer science called the actor model, which our frameworks sort of accidentally or intentionally wound up implementing, right? Even our cube message handlers were basically building around the actor model. And it talks about these cube message handlers essentially as the primitives of a language. And so you're basically talking about the next level up programming, Jim, and we don't have live living diagrams for that. I have been in my own work and in what I tell other people is, you're breaking out the paper and pencil diagrams. Okay, you're making sequence diagrams, and you're making class diagrams, and state diagrams are the three that I use the most. And they are really part of your package of deliverables. They go to, Jim, you mentioned documentation as a useful thing for a framework. Well, documentation of a delivered product is the same thing, and we have to have these diagrams. Fab likes to say, Fabiola de la Cueva, who created a DQMH, a frequent criticism of Actor Framework is that you're no longer programming in the block diagram. And that's true, but I think for any complex system, any complex software, we left the block diagram a long time ago. And so we do have to have these. What? Yeah, it has its ups and downs. I used to hate the LabVIEW project. I mean, when it first was released, I hated it with a purple passion, and I still kind of don't like it very much. But at the same time, the things it does for me as I've grown to understand and use the tool have grown. And it's like, okay, fine, I see its role. The LabVIEW project is not simply a tool for organizing how you present code to work with. It is a programming artifact. It's a part of your application. But it's kind of, when we're thinking of these larger systems, you can't fit it on a screen. And so, what are our visualization tools? And right now they're all static. Say what?
If you zoom out, you might be able to fit it on a screen.
Oh dear
Yeah, I was just
God.
gonna peek out. We're getting close to end of
Set me
time.
up, Lee.
Yes, so we're getting close. We're getting close to the end of time, and I hate to interrupt you, Alan, but I do like where this conversation was going. I like, Daniel, how you put it as like different mental models, and then different people might gravitate to different things. And I think this conversation has helped bring awareness to people. I've learned some things over what should I look at for my application? So that's a very good start, even though we can talk about this for hours. We have just about, let me check. Yeah, we have just about 10 minutes left. And I would have loved to make this 2-3 hours because I have so many questions to ask, but I'm gonna
Come to a GDEF Con.
fun.
I
was
you can have this 2 to 3 hour conversation.
I was there, everyone in the audience. Definitely go to GDEF Con if you've been enjoying this conversation. But yeah, so
I sponsor 2 of them, by the way.
nice. So Jim has hinted at this 3 times so far. The last question I wanted to bring up is this latest release of LabVIEW 2023 Q3 now has zoom in and zoom out capabilities for the block diagram. I know that this feature has been highly requested and highly awaited. I've personally had people ask me about this over the years back in my sales role. So I was really excited and honored to film the latest video about it. However, one thing that we've always said, and I believe you'll all stand by, is that good modular code shouldn't need zooming in. I wanted to get your quick thoughts, maybe 2-3 minutes each, so we can wrap this up. How do you feel about Zoom? Are there any use cases you're excited for? Are you concerned that it could lead to bad design and we need to put a warning up there? Have some fun with it. Alan, I know you have passionate thoughts. Do you want to?
I do have passionate thoughts,
Passion.
and my opinion is worth what you paid for it. Okay. And I've thought about this. I mean, just to pull the curtain aside, we had a green room session on this a couple of days ago to kind of frame some of our thoughts on this. And I realized that there's a couple of things going on. There's my personal view of it, which is actually different from of any tool really, which is actually different from the roles it might take on in a broader space. And I have to say that for my own work, there was a big deal. NXG, the big deal about LabVIEW NXG is now it has Zoom, and now LabVIEW, classic LabVIEW has Zoom. I could care less.
Now we can talk about something else.
Can we talk about something else now? Yeah, exactly, Jim. Thanks. Can we talk about something else now? Can we put those engineering hours to something else? I think there is a real moral hazard with a tool like Zoom, because I think it will enable people to do the wrong thing, in that they'll keep more and more and more stuff on their block diagrams, and they'll get busier and busier. And that one VI that you wrote, you will no longer be able to tell me the one thing it's supposed to do. Okay.
Zoom doesn't.
Okay. That's kind of my take. That's my personal take on it now. And Daniel raised a very good point about accessibility, and I think that I will not steal his thunder, and I will let him make some comments.
Daniel, do you want to listen there? Sorry, Alan.
Not quite done. And then I remembered that there's one case where you may very well have that very large complex diagram where being able to pull out in Zoom is important. And this is actually the downside to modularity. Modularity comes with a cost. That cost tends to be measured in performance of your software. We have one and only one optimization in software. And I refer to it as elegance versus performance. How pretty is your code? How easy is it to maintain? How easy is it to change? All that elegance, the art of what we do.
But that's often
right?
artificial.
Costs us something in terms of time.
That's an artificial complexity of the language and compiler and ID are working in.
But
your
there
module
are
is isolated and you have a penalty.
There are some regimes there, and I've worked a couple of applications where this was true. There are some regimes where you just need to go fast, and you can't afford the milliseconds that some of our architectures consume again and again and again and again. And in that case, you're going to wind up with a big diagram. And yeah, Zoom could be handy in that case. So with the moral hazard in mind, and again, if it's such a requested feature, that's going to get more people buying LabVIEW. And that's actually good for me in the long run because more people using LabVIEW is more opportunities. So those are, I'm conflicted about the Zoom feature.
No, I love that. Hey, there's
both
no
right
absolute truth, right?
They're both right answers. Yeah.
Daniel, I think Alan hinted at
Oh, sure.
your first answer to me was
Yeah, well,
immediately. Please go ahead.
where we started today was we talked about, we've all been using LabVIEW for this amount of years and all this kind of stuff. It means that we're getting a little bit older, and I've noticed, and I'm wearing the glasses now, and the monitors have been getting bigger, but the dots per inch has been getting higher, and so the pixels are getting smaller. And then when I have to use a laptop, if I'm out on the floor or something, that monitor is only 15 inches or so, and they keep cranking that, resolution higher and higher, and those 32 pixel by 32 pixel icons are getting harder and harder to see. So having that, okay, I can hold on control and use my mouse wheel and just get a quick, oh, okay, there's that. And then I'll pull back to actual size and look at the code. I will give some credit. Credit is due. If you look at the documentation online, I just checked it, and on ni.com, you search for, can I zoom in or out on the LabVIEW block diagram? There's a nice article, and it does say, like, hey, if you find yourself really needing this, maybe you need to create some sub VIs, get a little more modular.
Yes.
So they do say that, and I got to give credit for that.
Yeah, I think Daniel and Alan, you said this last time we talked. If you find yourself using zoom in and zoom out too much, think about modularity.
It's a code smell. You've got so much going on.
Yeah.
Daniel, I do actually need to thank you specifically for raising the accessibility issue, because it really is just not something that had occurred to me. I've solved that problem with my own vision deficiencies in a different way. But so I gotta thank you. I hadn't thought about it before.
It comes for us all.
Yeah.
The other thing I'd mention is nobody has a zoom problem at the end of the day. Like when I'm writing code, like I'm like zooming in and zooming out doesn't actually like check off any checkbox in my system requirements. And so this is just a tool within an environment to help me do some other thing that I'm trying to do. And typically it's I'm trying to get someplace, or I'm trying to get a picture of something. So we're gonna go back to analogies. So Google Maps, you have these different levels of zoom. Mm-hmm. If I zoom in high enough and I have the satellite on, like I can see houses and backyards and homes. At some point when I zoom out, the picture changes, and I'm no longer seeing features at that level. I'm seeing dots for cities and highways and rivers and national parks. I zoom out further, I see states and further countries. There's more than just the United States in the world. Whoa, that's cool. Wow, look how big Africa is. That's amazing. And you zoom out farther, and you start to sort of change just the frame of reference and the vocabulary you use for things. And so I think zooming in and out in one block diagram, if nothing changes, maybe isn't so helpful. It's like trying to read a book by cutting the pages out and laying it all out on the floor, right? And then stepping back, and it's like, I don't even need to turn the pages now. No, I think what we really need is probably for zoom in and out. Like if I hover over a VI and I hit a magic key and I do the wheel, why can't I zoom into the sub VI and I can sort of see its 32 by 32 pixels get really big and stretchy and go transparent. And now I've walked into this VI and I
stepped in, like you're redefining the step in debugging almost.
That would be kind of cool, actually.
I dig that.
If you have sub VIs, is there a reason why you couldn't even double click on a VI and have it all of a sudden expand and push all the code out? And now you're not seeing the icon anymore. You're seeing the code in context. So there's all these interesting ways that visual graphical programming can work. Zoom in and of itself is not a bad thing. I think defining a module with too many things going on in that module is a problem and a bad design. And so,
I think we all agree on that.
If we just let people zoom out on their, super monitors and plop code everywhere with no sub VIs, then we're setting them up for problems. So I was thinking maybe like the seatbelt warning in new cars. If you zoom out on the diagram and you're coding for more than like 5 or 10 seconds, it like gives you a little red dot beep.
We'll get the right people on this.
30 seconds, and it sees you actually writing code that's like beep, beep, beep.
Okay, well, thank you so much. I'll just add my quick thoughts. It was fun when I was shooting the video. They caught me just like zooming in and out.
Oh yeah.
But no, I love everything. I love that. Unfortunately, we are out of time, but thank you so much, Alan, Dan, Jim, and thanks everyone for attending and watching this. If I hope you found this useful and learned a few things. I know that I have. And the next time you're about to develop an application, you'll now have a few good successful frameworks to consider. So thanks again, everyone, and have a wonderful day.